Aloha and welcome. In this video, we're going to be talking about cryptographic principles. We're finally getting into the cryptography chapter, and we're going to be going over cryptographic principles and cryptographic primitives. So let's go ahead and look at our textbook here. So the first thing we're going to talk about, cryptographic principles. So we've got three different definitions here. One is cryptography, and cryptography is the science of secret writing with the goal of hiding the meaning of a message. So essentially, cryptography is you want to take a message and hide it so that somebody can't read it. Cryptoanalysis is kind of the other side of it. That's basically the science of breaking cryptography. So you've got the side that's trying to obfuscate the message and make it unreadable. Then you got the other side that's trying to figure out what it is. And then cryptology is the study of both of those sides, the cryptography and the cryptoanalysis. So cryptography provides four basic security services. One is confidentiality. We talked about that before. It's also known as secrecy. Data can only be viewed by authorized entities. We've got the integrity side. So integrity says that the information that you receive has not been modified by unauthorized parties in any way, shape, or form. So that's the I part of the CIA triad we talked about before. Then we've got message authentication or data origin authentication. That's just saying that you can verify that the source of the message was sent from who you think it was. And then lastly, we've got something called non-repudiation. Non-repudiation just means that a person can't deny that they sent that message. So when we talk about non-repudiation, there's two times really we talk about it. One is when you've got like an email. If somebody was using digital signatures or something, they sent you something, they can't deny that they sent it because it's using their non-repudiation security service, which is, we'll find out later, digital signatures. And then for example, when you're in an operating system or when you're in let's say a Linux environment and you do something and there's a log of, file modifications or something like that, because it's your account that's doing it, you can't say that it was somebody else because it's not a shared account, it's your account. So that's non-repudiation right there. So essentially four things: confidentiality, integrity, the message authentication, and non-repudiation. So you want to make sure the stuff is secret, not viewed by unauthorized people. It's not modified by unauthorized people. It came from where we said it came from, and the person that sent it can't say they didn't send it. So then we get into the cryptographic primitives. So a primitive is basically a basic building block. So when we talk about cryptographic primitives, we're talking about the basic building blocks of cryptography. And those are when we look at this, we're going to say a cryptographic primitive provides a security service. So the four cryptographic primitives we're going to be talking about are encryption, cryptographic hash functions, message authentication codes, and digital signatures. So with encryption is defined as using an algorithm and a key to hide the meaning of a message. So encryption, it can be one of two types. It can be asymmetric or it can be symmetric. Symmetric means, goes both ways. And what they mean by that is you're using one key to do both the encryption and the decryption. So you just have to have that one key. With asymmetric, though, it requires one key for doing the encryption, and then it uses another key for doing the decryption. So symmetric keys, they can use either stream or block ciphers. So a stream cipher is where the encryption is done on the data one bit at a time, and a block cipher encrypts the data one block of bits at a time. And this encryption is providing the confidentiality security service that we talked about. We've got the cryptographic hash functions. The important thing to know about hash functions are they output a certain size for whatever size inputs come in. So no matter what the size of the input, it can be this big, it can be this big, it can be whatever size, the resulting string is going to be fixed length. It's going to be always the same size. So cryptographic hash function provides the data integrity security service. So this is going to be guaranteeing that whatever you apply this hash to when it's received, you can look at the checksum for it and verify that that output of the hash function matches, and therefore you know that the thing that went into it is the same. So you get the message, you get this this hash function, you apply the hash to it, and if it comes up with the same thing, you know it's the same message. Then we have the digital signature. And the digital signature uses a cryptographic hash function and asymmetric encryption to provide the data integrity, the authenticity, and the non-repudiation security services. So uh, I have to go back one step here because I forgot message authentication code, MAC here. So message authentication code uses a cryptographic hash function and symmetric encryption to provide the data integrity and the authenticity security services. So your hash function, as we said right before that, that's doing your data integrity part. The asymmetric encryption, that's going to give the authenticity. In other words, hey, it did come from that person. So, using those two things with message authentication code, you know that you've got that hash function, the symmetric encryption. So you know that it has, well, that provides the data integrity and the authenticity security services. And then lastly, as I was saying before, digital signature. The digital signature is using a cryptographic hash function and asymmetric encryption to provide the data integrity, authenticity, and non-repudiation security services. And we look at a flow chart here. We've got cryptography up here. This isn't a flow chart. This is just I guess you'd say a graph of it. But under cryptography, we've got the four different primitives here. We've got encryption, we've got asymmetric and symmetric, and within symmetric you've got stream cipher or block cipher, just saying how you're doing the encryption. Then you've got the second one, which is cryptographic hash function. This is the hash function. You're taking in whatever size input and outputs the same size message for everything. Then message authentication code. This is the one where it's going to use a hash function and a symmetric encryption to do the data integrity and the authenticity. Then lastly, we've got the digital signature. The digital signature is the one that's going to do the heavy lifting. It's doing data integrity, authenticity, and the non-repudiation. So that's it for the for the section. Go ahead and check this out, and read through it, go through your definitions, know the differences between things, and yeah, if you have any questions, feel free to reach out, jsj3@hawaii.edu. Always happy to help out. Other than that, I will see you in the next video. Aloha.